Recording start. So what we are discussing is basically something called as concept of weighing machine. What is the concept of weighing machine? See examples. So first of all, tell me, what does a weighing machine measure? Suppose you are standing on a weighing machine, enough. This is you. So when you are standing on a weighing machine, what exactly forces are applied on you? Which forces are applied on you?
So gravitational force.
Gravitational force due to Earth is applied on you. So your mg is acting in this direction. What else? Does this
I
weighing
guess a very
machine?
little amount of this one magnetic force. I guess little bit, like
But it
very
is
little.
not required as of now because magnetism अपन कर नहीं रहे ना. We are not talking
Oh,
about this much. I know we are talking about those forces which are at least there. So so tell me what all forces are there. We have not studied anything about gravitational force, so we'll not include them as of now. We'll include them later on. But anyways, mg is there in the downward direction, and this weighing machine and this man is in contact with each other. So basically, the weighing machine will apply a normal reaction on the man in the upward direction. So this is basically the normal reaction on man due to the weighing machine. Yes or no? So similarly, the same normal reaction will this man also apply on this particular weighing machine, and this is the normal reaction on the weighing machine with respect to man or because of man, right? Yes or no, guys? So basically, what
yes,
force
sir.
does this weighing machine measures? Please remember, weighing machine never measures this mg acting on you. Weighing machine never measures this mg. It measures this force. So please remember a note. Weighing machine always measures the force acting on it due to the contact between the object and the machine. Is this clear? Is this clear, guys? So always remember, the weighing machine will measure this force. And how will it give reading then? So always remember the reading. Always you see the reading in kgs, right? You see the reading in kg, right? So the reading of the weighing machine is basically whatever this normal reaction is there. Whatever this normal reaction is there, divided by the acceleration due to gravity. This thing will come in kg. So that will be the reading of your weighing machine. Is this clear? Is this clear, guys? Okay. So now let's talk about one more heading. Apparent weight of an object or a man in a lift. So we'll see the apparent hello.
Yes, sir.
So we'll see the apparent weight of an object or a man inside a lift. So let us see. How will you measure this weight? You will measure this weight using what? Acha, by the way, if you want to know what should be the reading of this weighing machine, then can you see over here, if you can just find out this n anyhow, you can already find if you can find this n, automatically you'll find out the reading. Yes or no? Yes or no, guys? So the basic thing is to calculate the value of n to find out the reading. To find the reading, find n using free body diagram of this object. Can you see this object was at rest or accelerating, depends whatever it is. So accordingly, ability of man or not. Okay guys, shall we start? Guys, did you write the heading? Did you write this note, concept of weighing machine?
Yes, sir.
Okay. So suppose first, the lift is initially at rest or it is moving with uniform velocity. See, please remember guys, if the lift is moving with uniform velocity, that implies that the forces are balanced, right? So suppose there is a lift and there is a weighing machine placed inside the lift and there is a man standing on the lift. Enough. Let's say this lift is either at rest, this lift is either at rest or it is going up with a constant velocity or it is going down with a constant velocity. Till the time it is not accelerating, it won't make a difference. Here when it is at rest, the velocity is zero, right? Yes or no guys? In all of these cases, what will be the forces acting on the whole system? Will it be like, this man, I told you, we'll be just measuring the normal reaction which is acting on the man and then we'll find it out. So what all forces are acting on the man? Is there this mg downwards and this n upwards? Yes or no? In this case also mg downwards, n upwards. In this case also n upwards and mg downwards. Yes or no? Yes or no, guys?
Yes, sir.
So can you see the real mass of the object is how much? M. And the real weight of the object is how much? Real weight of the object is how much? M into G. Yes or no? Can you see mass and weight difference? Hai na? So in this particular case, in all these cases, this, since the object is in equilibrium, can you see V equals to 0 or moving with constant velocity up or down? So since the object is in equilibrium, or man is in equilibrium, hence, can I write N should be equals to mg? Yes or no? Yes or no, guys?
Yes, sir.
So basically N should be equals to mg. So here in this case, always remember the apparent weight, which is nothing but the normal reaction or basically this particular thing, is equal to mg. So here in this case, always remember whenever the lift is at rest, real weight and apparent weight are equal when the lift is at rest or the
The
lift is,
apparent weight is the weight which is pushing downwards. Like
no,
the
apparent weight is basically the force which this object feels on it. Okay, or basically what he measures, what he applies on the machine. That is basically the apparent weight of this guy on the machine, right?
so
Whatever
what
normal.
apparent weight is like lift की पूरी weight.
No, lift की पूरी
Then
weight नहीं है भाई. Apparent weight of this guy on this machine. What force are acting on the machine? The normal reaction is acting on the machine, right?
yes
The
sir.
same normal reaction in the opposite direction. तो ये वाला normal reaction इस बंदे का
Apparent.
apparent weight है. This
Okay.
normal reaction is basically the apparent weight. Shall I write? This is the apparent weight.
हाँ. हाँ. Clear.
Is this clear, guys?
हाँ sir.
Okay. So real mass is also m. So what will be the reading in the machine? What will be the reading in the machine? Will it be equals to n divided by g, and n was equals to mg divided by g? So g से g will get cancelled. So can you see real mass and apparent mass are equal in this case? What is this reading? This reading is basically the mark which will be appearing on the machine, right? Yes or no, guys? So is this clear? Any doubt in this first case? Please write it. We'll start with the second case now. Whenever you're done.
So done.
Now the second case will be when lift is moving upwards with certain acceleration.
Sir, the apparent weight is zero, the same as the weight
Yes.
when the lift is at rest.
हाँ, तो जितना वेट तेरा है एक्चुअल में उतना ही दिखेगा.
हाँ, ठीक है.
बट लिफ्ट मूव करने लग जाएगी तो ये वेट ऊपर नीचे
सर,
होता
हमारे
है.
पास सैटरडे कोई एग्जाम है ना?
हाँ, this Saturday you have a physics exam, relative motion in one dimension.
Oh yeah, sir, by the way, Friday को I won't be able to attend the physics class.
Why?
So I'm going somewhere out.
Where?
Sir, मैं फुटबॉल खेलने जा रहा हूँ ना, तो I won't be able to attend. Could you record that and send it to me?
हाँ, recording तो होगी obviously.
Yeah, fine.
So lift is moving upward with a certain acceleration. So see guys, in this case, there is this lift in which a man of mass m is standing, and the lift is going upwards with an acceleration, let's say a. Okay, is this clear, guys? Lift is going up with an acceleration a. So if I say this, what all forces will be acting on this man? So will this mg act on the man in the downward direction, and will this normal reaction act on the man in the upward direction? Yes or no? Yes or no, guys?
Yes, sir.
So if these forces will act, so can you see, for this man to go with the lift in the upward direction, the same, this n should be bigger than mg, right? So from here, can I write n minus mg is equals to a, right? Can I write it like this? Guys, can I write it like this? Hello?
Sir, n minus mg is equal to
शिव हाँ वो एक पीस दे कौन सा लेगा कोई सा भी रख दे अभी खाना है
yeah. So basically mg is equal to n plus a, so you can write that.
ये रहा एक सेकंड गाइस गिव मी 2 मिनट्स
नहीं बड़ा मत छोटा ये
निकालने की थोड़ी थी ऐसे हो जाएगा
क्या
मेरे को नीचे लगती है आई एम नॉट क्रेजी अबाउट दिस एक चम्मच लाके देगा क्या
चम्मच ही मैं इसको बोला कि चम्मच लेके आ गया
चल so n minus mg is basically equals to m into a. Yes or no? हाँ Tanish, you were
Yes.
asking some doubt.
basically mg is equal to n plus ma.
हाँ, so mg equals to n minus m. पर अपने को we don't want
So, but
mg,
if
right? We want
that is
n.
equal, so if mg is equal to n plus ma, then how will the lift move upwards?
If mg is equals to, if the lift
Basically,
is
normal force is greater.
normal force is greater in this case because the accelerating up, no? So with the lift, even our man was accelerating upward with an acceleration. He was
ठीक है.
standing inside a lift at rest, right? So whatever be the acceleration of the lift, that will be the same as the acceleration of the man. So due to which, what will happen? Our man, it will go up with the same acceleration. So can you see n minus mg equals to m? So when you solved it for value of n, so can you see over here, n is basically m into g plus a. I told this n acts as your apparent weight, right? So you can say this is m into g effective. So can you see this part is basically g effective?
Yes,
The
sir.
effective acceleration due to gravity has increased. Yes or no? That is why the weight which this object will experience, it will be bigger. Okay? Is this clear, guys?
Sir,
So हाँ बोलो 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 बोलो. The effective acceleration due to gravity has increased. Shall I write it this way? The effective acceleration due to gravity increased from its normal value. What was the normal value? In spite of writing normal value, I will write it usual value. Right? So can you see G became G effective? So basically this is your apparent weight, and please remember, since G effective is greater than G, then you can say apparent weight in this case will be greater than the real weight. So basically the man, if he is, let's say, 60 kg, he will see the reading as,
so g effective is g, like the 10 meters per second plus the
plus
acceleration,
the
right?
acceleration of the lift. So whenever the lift is going up, so this guy will feel like he has, his weight has increased. Have you ever seen ki, suppose if the lift suddenly goes up, have you experienced the force in the downward direction when the lift
Oh,
starts? Yes, that is
yeah.
that force. So suddenly, why do you feel that much force downwards? Because due to the acceleration, the G effective has increased for you. So the reading in this case will be equals to n divided by G, which will be m into G plus a divided by. Is this clear? I'll give you one question regarding this. So
Apparent
now,
weight is real weight, effective acceleration. So could you scroll up?
yes,
Yeah, done,
write
sir,
it.
done.
Whenever you're done writing, just tell me. Then I'll give you one question, and then you need to solve it using the same logic. Okay? Guys, we are doing the easy part first. Once you're done with the easy part, then we'll look at the higher problems. Well, the relation between the accelerations, if you remember in the previous class, that is basically something a higher concept. And there are various methods which are given by different people. So we'll use one of them. We'll try to use from the simplest and then we'll go to the toughest. We'll not learn all. Well, there are 3 or 4 methods are there, out of which we'll only learn to use only 2. Okay. Clear, guys? Any doubt? Guys, are you done?
Yes, sir.
Hello, question लिखो. Or shall I give all the questions later on? चल अभी लिख लो. A man of mass 60 kg is standing on a weighing machine. Standing on a weighing machine inside an elevator accelerating upwards with 2 meter per second square. Find the reading of the machine. So basically his mass, actual mass is how much? 60 kg. But what he will measure on the weighing machine, that is what you need to find out. You need to find out what is the reading of the machine, or basically the apparent mass. Fine.
The G will be taken as minus 10 or 10.
G, take it as 10. Draw the diagram, take it as 10. Take the magnitude of G as 10 meter per second square.
So like the answer will be
72.
60 into 12.
Hmm.
217200 kg. No, 7200 kg.
I suppose this is your man.
So this weight is 7200, right? ज़्यादा
7200 नहीं, इसका weight 720 Newton आएगा. Okay. Weight is a force. And the reading will be that 720 divided by G. So N will be equals to M into G plus. Okay, so this will be equals to 60 into 10 plus 2, which will be 720 Newton.
नहीं
Yes
सर
or no?
7200 होगा ना. Sorry, so 720, yeah.
Then the reading will be basically what? Reading will be N divided by G. So basically this 720 divided by 10, cut 72.
Once again, sir, N is the normal force, right? Upwards.
This is the normal reaction. and this in newtons,
N by G क्यों है?
because the reading is basically the normal reaction divided by G.
Is it a rule or something?
अरे अभी पढ़ाया भाई, सबसे फर्स्ट कॉन्सेप्ट फॉर दिस ओनली,
Why sir?
है ना, n by divided by G. ठीक है,
हाँ.
चलिए. Now the third case, when lift is moving downwards with an acceleration a, but please remember, but a should be less than G. We'll see what exactly happens when a is greater than B. For example, suppose again this lift and there is this weighing machine. This guy is standing on the weighing machine. The lift is accelerating downwards now, but this acceleration's value is less than V. Okay. So when this will happen, can anyone tell me what exactly will N be, mg be? Can anyone tell me the equation? What will be the equation over here? Will mg be bigger in this case? So mg minus n is equals to ma. Yes or no? Tell me whether the equation which I wrote is correct or wrong. What are the two forces acting on the man? Mg and n. Since the object is accelerating downwards, that's why mg should be bigger, right? Hello?
Yes sir.
Does this equation make sense to you or not?
Yes, sir.
Yes sir.
नहीं, यस सर मेरे डर के कारण मत बोलो, हाँ है ना, समझ में आया उसके हिसाब से बोलो. ये इक्वेशन
हाँ,
पता है, समझ में आया कैसे किया था ये? If the acceleration of the lift is downward, that implies the man is also accelerating downwards with the same acceleration a. So can you see mg, it should be bigger for this man to accelerate downwards, yes? So we wrote the equation. When we wrote the equation, we got mg minus ma. So can you see n will be equals to m into g minus a, and this n will be equals to m into g. Please remember, this is the apparent weight. The normal reaction is basically the normal, this thing. And can you see from here, if you compare, this will be equals to g effective. So from here, g effective will be equals to g minus a. So can you see g minus a, since a was less than thing, hence g effective will be. So in this case, the apparent mass or apparent weight will be less than the real. Please remember this thing, no? When the lift is going down, then you feel a little bit light, right? When the lift goes down suddenly, do you feel a little bit light in your stomach? Yes or no? Do you feel that? Hi or no, guys? So anyways,
Sir, I was talking from.
no problem. So the reading
Sir,
is
apparent
basically,
and the weight decreases.
yes. So basically the reading will be this time less than the apparent mass, will be lesser than the real mass. Please
If
write
the
it.
acceleration is greater than g, then
Then that is the new case. After this case, we'll discuss that.
okay. Mg minus na. is equal to N. So how's n plus ma? So could you scroll up actually, like on the diagram of this? So the n will be equal to mg plus ma is equal to n, right? Wait. N is
No. Always remember this MA will come always at the end on the right hand side. Whatever forces are acting, you'll do those forces.
MAs of the full body.
Hmm.
हाँ ठीक है.
Yes, done.
हाँ. तो मैं ये पार्ट लिख रहा नहीं हूँ, मैं नोट से ले लूँगा.
ना 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 देखो,
बुक बहुत दूर है.
उठ जल्दी उठ, भाग के जा लेके आ. Shall we discuss the fourth case now? What will happen when the acceleration of the lift is greater as compared to?
The object will fall down, like मतलब it'll go inside the नहीं क्या? If it's greater than the rope will break the.
No 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 no. ऐसा कुछ नहीं. There is no rope attached to the pulley, or we're not thinking anything which is outside this lift. We're only talking about the man which is inside.
Okay.
चलिए. Case number, guys, are you done writing?
Yes, sir.
Yes, sir.
Now fourth part is lift accelerating downwards.
तो सैटरडे का कौन सा टेस्ट है?
Kinematics, motion in 1D, and relative motion also in 1D, है ना?
Yeah, fine. So you said you will take it one by one, like
हाँ
first motion in straight line, then next week plane.
हाँ, I'm taking like this only, motion in straight line, but it will contain the concepts of relative motion in one dimension.
Okay.
Yeah? So lift accelerating downwards. Now when the lift is accelerating downwards with an acceleration greater than g, now see what happens. So tell me this particular thing. Suppose, guys, if there is an object, if it falls freely under gravity, then what is the maximum acceleration with which this object can fall?
So maximum what?
Freely. An object can fall freely under gravity with a maximum acceleration of equals to g. ये सबको पता है ना?
Yeah.
If this object is falling freely, then it can fall with a maximum acceleration equal to g. Ab, when your lift goes with an acceleration greater than g, what has happened? What happens over here? See, suppose this is the guy. Again, normal reaction mg up, right? So now see the previous case, guys. If a will be greater than the g, then g effective will be negative. Will g effective be negative? Can you see, if g a is bigger than g, then will g effective be negative? Here in this case it was positive, right? It was positive, right? So when acceleration is greater than g, that implies acceleration of lift when it is greater than g. This implies that lift is falling faster as compared to the guy. Did I tell me this particular thing? Did I attach the man's feet on the machine? Can he step up or step down from the machine, right? Can he climb up the machine? Can he come down from the machine? Yes or no? चलो उतर सकता है क्या? Yes or no? So if the acceleration of the lift is greater than that of the man, so basically what happens from ground frame of reference, if you look at from ground frame, you will feel like this guy is falling with an acceleration equal to g, whereas the lift is falling with an acceleration a, and a is greater than g, right? A was greater than g, right? So basically what happens, the man loses the contact from the lift, and after some time will touch the roof of the lift. So basically this man will lose contact and will see, if I talk in frame of reference of the lift, so if I talk in the frame of reference of lift, that implies lift is at rest. And do you remember the man going, so basically this man will go up with an acceleration of d minus, oh sorry, a minus. So can you see, if you try to do the relative motion thing, I cap, j cap, do you remember guys? Plus minus relative acceleration of man with respect to lift will be equals to,
अगर लिफ्ट गिर रही है एक बिल्डिंग से, मतलब ऊपर का रोप कट हो गई है, and just freely falling,
हाँ तो वेट जीरो हो जाएगा,
and he will fly.
हाँ नहीं, he will lose contact with this thing, he will not go up or down because lift also falling with the same acceleration and he also coming with the same acceleration. Okay,
So ये मरेगा नहीं.
मरेगा नहीं, मर सकता है बाद में, जब टकराएगा तो मरेगा कहीं ना कहीं पे. But anyways,
First contact is not with the person.
So can you see guys, acceleration of man with respect to lift is basically a minus g, and since a minus g was positive, hence can you see in the positive direction. So lift ke respect mein this guy will go up and ultimately touch the roof of the elevator. Is this clear? Normal reaction will become zero because as soon as there is no contact, the normal reaction becomes zero. Yes or no? Please write it down from here.
Man loses contact from the left and touches roof. So could you scroll down? A minus G is, मतलब ये A minus G के acceleration से ऊपर जाएगा.
सही बात है.
मैग्नीट्यूड a minus g acceleration के मैग्नीट्यूड से ऊपर जाए.
सही बात है, बिल्कुल सही बात है.
ओके,
AML क्या लिखा है?
यहाँ पर
ये नीचे फॉर लिफ्ट
acceleration of man with respect to lift, relative
minus G minus A. Acceleration of man with respect minus G plus minus A minus G.
There is the acceleration of man minus the acceleration of the lift.
Normal force zero.
Normal force will become zero because it will lose contact.
normal
from
force,
the
basically
machine, right?
the force applied by the man on the left will be 0.
Huh. There will be no force applied by the man on the lift, on the machine. Clear? Is this clear?
Yes, sir.
Next case, fifth case. Lift falling freely. When the lift is falling freely, that implies the acceleration of the lift is equals to g. Yes or no, guys? If the lift falls freely with an acceleration equal to g, so even man is falling with the same acceleration, lift is falling with the same acceleration, the g effective becomes 0, which is g minus a, and the normal reaction also becomes. That implies man loses the contact with the lift, but doesn't go up or down, you know?
He'll just like stay suspended in the air, right?
Suspended in the air. With respect to lift, we are talking, you know?
Oh. But like he'll come down now as well.
He will come down. Obviously, he is coming. Ground frame, see, even the lift is falling, even the man is falling. गेट बंद कर दे शानू. Are you done, guys?
Sir.
So these are all the cases of the lift. Anna? Any doubt? Some direct question can come on this particular thing, then you can do it directly, right? Yes or no? The direct questions can be solved directly on this. So this is one of the type which is very important. Achha, I'll give you some questions in which this platforms and elevators are involved. Hai na? Suppose there is a painter over here. Have you seen a painter which who paints the wall of the building? Like he uses this kind of setup, right? Suppose. Huh?
The one lift, like I can't explain. मतलब ऊपर नीचे रोल होता है शायद. तो केमिस्ट्री सर आपके घर में रहता है?
नहीं, we live in the
Nah,
same
not
flat,
really.
but not in the same room.
I heard Kunal.
Yeah, my roommate's name is also Kunal.
Bro, there are many people named Kunal in this
Hey
world.
bro,
It's
I was
not
just guessing.
Kunal,
Calm down.
No, he lives in, we live in the same flat, but different rooms.
Achha.
Dude, relax. I'm not trying to be angry.
So, guys, can you see there is this painter, and let me check. There should be one question regarding the same. I'll just give it to you. 2 minutes, guys. A painter of mass m stands on a platform of mass small m and pulls himself up by 2 ropes which hang over the pulley as shown in the figure. He pulls each rope with a force F. Okay? Please, some data is important. He pulls each rope with the force F and moves upward with a uniform acceleration. Then question is find it. So please remember, if A has been asked, so you need to find A in terms of F, M and small m. G will be allowed, right? Because G is a constant, we know the value of G, so G is allowed. Chalo, do it. How will you start with the question? FBD of man as well as the platform. That's it.
People reach out with the force F and work with the acceleration A. Find A. So find A, right? Sir,
Yeah.
I need the weight and all of
The mass is given to you. Man has a mass capital M and this has a mass small m.
okay. So M M A M plus M. Yeah. So is the answer 2F by M plus M?
Let me check. Now what did you say? 2f plus question number 24. What did you say, bhai?
The 2F by M plus small m.
No, it should be 4f. And that too here
Okay.
after this minus g. See guys, first concept. I told you, can you see this force have been directly applied to the string? So basically what will be the tension in the string? What will be the tension in the string? The blue F's which I have drawn is basically the force applied by the man on the string. So basically the force applied by the string on the man, will it be like this, the same F? Will it be like this, the same F? This force F will act as the tension in the string. So F, I told you this about this point, right? If you apply a force directly on a string, then that becomes the tension in that string, right? Yes or no? F, same here, F and F. I'm not drawing the whole thing, right? After this, this man has a weight downwards, capital Mg, and this platform will try to push this man upwards with capital N. The same capital N will be applied on this platform in the downward direction, and this platform has a small mg mass downwards. So what all forces are acting on the man as well as the platform? We just need to make the correct free body diagram of platform. Yes, what was the weight of the man and what was the weight of the platform? Both were acting down, so capital Mg and this small mg. Yes, yes or no, guys? Are yes or no?
Yes, sir.
Is this force and this force counted for? Yes. Hello.
Yes, sir.
Now after this, what all forces are acting on this man? Can you see these two F's? These two F's are acting in the upward direction, and also this N is also acting in the upward direction. Yes or no? So if I draw this thing, this F plus F will become 2F, and one more force, the normal reaction. So basically these are all the forces which are acting on the man and this man is going upwards with an acceleration. Similarly, platform. Yes, guys, can you tell me about the platform? Can you see the normal reaction acting in the downward direction? And can you see this F and this F? These two F's are acting in the upward direction. Yes? So when you solve it, this is also going upward. So n plus 2f minus capital Mg is equals to capital Ma. 2f minus small n plus Mg is equals to small m. Please try to understand this equation. Tell me if you have any other doubt. Can anyone explain me why did these equations got formed? How did you form these equations?
Yes, sir. So basically, so I need to see the diagram. So can you zoom out?
Zoom out तो नहीं कर पाऊंगा मैं I don't think so. I think just up and down.
So basically, the first equation is n plus 2f is equal to ma, right?
No. N plus 2f minus this mg, bigger force minus smaller force. So these two are combining their efforts together and opposing this mg to give this acceleration. So the bigger force will be the sum of all the forces here minus the smaller force equals to m.
Yeah, is equal to ma. Yeah, fine.
And
And
similarly,
second
in
one,
this, n and mg were opposing, and 2f was trying to take the object in that direction. So can you see 2f taking up 2f minus n plus mg equals to m. Is that clear, guys? Solve it,
yes,
please.
Yes.
Now solve it and tell me what is the answer.
sir. Okay.
Acha, add all of them.
Yeah, so n cancel, 2f will become 4 minus mg plus mg equal to ma plus ma.
Add this equation and this equation together. So what will you get? N and n will get cancelled out. 2f will become.
So the answer is 4f minus g bracket m plus m bracket then by m plus m.
So if I divide it by m plus m, so it becomes. So can you see your mistake? Where did you do the mistake? Is this clear, guys? Answer.
So how's it?
Divide this. Divide the whole thing by m plus m.
Oh, yeah. What?
Okay. Shall I give you one more question? Just like this. Okay. Suppose. Can you see this thing, guys? Basically, there is a elevator in which there is a man, and the elevator is basically connected to the string, and the other end of that string is basically with this man. So now the question is,
So what's the question?
This is the question. Find the force required by the man in pulling the string.
So I had a physics test today.
How much
So 19.
out of 20? ठीक है. Nice. कहाँ पे एक मार्क कहाँ गया?
Sir, that question was like the slope of like from velocity and time graph, right?
Acceleration.
They like go between 2 points. Two
Hmm.
points.
Hmm.
That was instantaneous acceleration.
तो instantaneous थोड़ी था. If it is
Next,
between 2 points, it is not instantaneous. It's average.
so I clicked average, so I got the wrong answer.
Was that a straight line?
I don't think so. हाँ, it was shared.
So फिर it will be equal. When the line is straight, then average and instantaneous are equal.
So answer is
दोनों both.
I got wrong.
क्या पता फिर मेरे को बताना question. Send me a screenshot of that. Okay. So find the force required by the man for pulling the lift such that it remains at rest. Second, it goes up with a constant acceleration of कितना दें 2 मीटर पर सेकंड किक स्क्वायर की कुछ और what acceleration से लगे 2 मीटर पर सेकंड स्क्वायर राइट अच्छा let's make the question a little bit more interesting. Let's say this man is standing on a this man is standing on a weighing machine inside the lift. Okay, this lift is of mass 40 kg. Lift with the weighing machine, whereas the mass of the man is basically, instead of writing it capital M, is equals to 80 kg. So the man has a mass 80 kg, the lift has a mass 40 kg, and now the question is find the force required by the man to pull the lift such that it remains at rest, and second it goes up with an acceleration. Please remember, if the man is pulling the lift with pulling the string with a force F downwards, then will there be a tension F produced in the this thing? Yes or no? Guys, did we discuss this concept? Hello? Last part.
Hello.
Hello. Can you hear me now?
Yes, sir.
Chalo, try to find out. Also find the reading of the machine for both parts 1 and चलिए शुरू हो जाए. Please start. What is the only thing which you will be doing? You'll be drawing the free body diagram and then solving the question.
So if it remains at rest, then the force is zero.
Nah, पकड़ के खींचना पड़ेगा ना उसको,
ओके, नहीं तो नीचे गिर जाएगा.
नीचे गिर जाएगा अदरवाइज.
Oh, okay, got it. The weight of the thing. Fine. So answer will be 120.
नो.
हैं?
गैस मत कर, डोंट गैस द आंसर बेटा,
Wait.
डोंट गैस इट, ड्रॉ द एफबीडी. टेलिंग यू नो, एफबीडी बना ऑटोमेटिक आंसर आएगा.
Yes, sir.
डन. guys, are you done? See, how will you do this question?
The first one should be 120, sir.
First one should be 120. Let me check. तो देख भाई, कभी तेरे पास ये आदमी है.
So first one, N is equal to M. Right? Normal force is equal to mg plus ma. Ma is 0.
FBD of man if I draw, तो मैन पे लग रही होगी नीचे की तरफ उसका वेट 80 g डाउनवर्ड्स. यस और नो?
Yes, sir.
The normal reaction from the machine or the normal reaction from the platform, right? I'm telling you, this weighing machine is attached inside this thing, inside this cabin. So this normal reaction up. Apart from this, can you see one more force which is acting on the man? This F. So one more force F. Now second is FBD of lift. So for the lift, this normal reaction will be acting in the downward direction. So I'll be drawing this thing in blue. So can you see the normal reaction which is acting on the lift? This normal reaction which the lift was applying on the man, the same normal reaction the man will apply on the lift according to Newton's third law of motion, right? So this normal reaction 1, its own weight second, and can you see this force is acting on the lift? So basically there are how many forces? 3 forces on this as well. The weight of the lift 40 g downwards.
How's 80? Should it be 40 g?
It is 40 g, no? This
40
is lift.
plus 80.
ना wrong. वहीं पे तो गलत हुआ तो. ये normal reaction was acting now. So from here you get two equations. You get N plus F for this object to be at rest, N plus F should be equals to ATG, and for this F should be equals to N plus 40G. So basically I can solve it like, F minus N is equals to 40G. So can you see guys, F plus N 80G hai and F minus N is 40G hai. So I think I can solve it. What do you want? What do you want? What is the force with which? So we don't want normal reaction, so add 1 and 2. Sir, why are we adding it? Because on adding it, N and N will get cancelled out, right? Plus and minus N.
I didn't ask the question.
Huh?
कुछ नहीं sir.
The 2F will be 80G plus 40G. तो तेरा जो F आएगा वो कितना आएगा? 120G divided by
So how's the N acting downwards for FBD lift?
because the lift is applying a normal reaction upwards on the man.
Okay, fine.
So man is applying lift downwards. So basically 120G it will be equals to 60G and this will be equals to 600 newtons. Is this clear guys? This is the value of F. Acha, what will be the value of N for part 3 we need to do, no? What will be the value of N? N will be 200. Can you see if I put 60G over here? 60G over here. So see, N will be 20G. 20G is 200 Newton. So this is how you solve this type of question. Any doubt? And I think you can do the next one as well. Next one, what will be the only case? What will be the only difference? The only difference will be for the second part of the question. For man, N, F will be upwards, ATG will be downwards, and for lift, N will be downwards, its own weight 40G will be downwards. Can you see no change in the forces? Yes or no? But the only difference will be it will not be at rest. It will be moving upward with an acceleration of 2 meter per second square. And here also this lift is also moving with an acceleration of 2 meter per second. Are you getting my point guys? So this is the only difference in the first case and the second case. Make the equations again in this case and then try to solve. Is this clear? I'm leaving the second question as the homework for you. Second part. Or do you want to do it now? Hello?
Yeah.
अभी करना है कि बाद में घर पे करोगे?
Sir, early break.
कोई अर्ली ब्रेक नहीं, 20 मिनट अर्ली ब्रेक कुछ नहीं.
मजा आ जाएगा सर.
नहीं, पागल है क्या? अभी कुछ नहीं. नहीं, फिर ऐसा करोगे तो मैं एक काम करता हूँ, मैं आपसे ना कुणाल सर को रख देता हूँ. लास्ट लेक्चर में I'll plan Kunal sir's lecture so that this
huh? The Kunal sir doesn't give breaks sir.
हाँ तो that is why ना. इसलिए तो मैंने सोचा कि मैं पीछे कर देता हूँ ना, मेरा लेक्चर आगे शिफ्ट कर लेता हूँ, उनको पीछे दे दूंगा. Anyways,
केमिस्ट्री समझ नहीं आता लास्ट लेक्चर में.
हाँ कोई बात नहीं, फिजिक्स भी समझ में नहीं आता. वो तो फिजिक्स में तुमको क्या कभी कभी 5-10 मिनट पहले छोड़ देता हूँ, बट इट इज बिकॉज क्योंकि उस टाइम पे नया टॉपिक स्टार्ट करने से कोई फायदा नहीं. दैट्स व्हाई आई डोंट स्टार्ट अ न्यू टॉपिक एट दैट मोमेंट ऑफ टाइम. बट एनीवेज, चलिए, इज दिस थिंग डन गाइस? Is this thing done? So in spite of writing a question, let's discuss the next concept, next type of force. Till now, how many forces have we studied? Guys, till now, how many forces we have studied? We have studied 3 forces, right? Gravitational force, especially we studied weight, then we studied normal reaction, right? And then we studied tension in a string. So these are the 3 forces which we have already studied. Now the 4th force is basically spring force. Okay. Hello.
Yes,
Now let's bring a spring. So let's say this is your spring. Everybody has seen a spring, right? Everybody has seen
Yes,
a
sir.
spring, right? है ना? ऐसा तो बोलना नहीं कि नहीं करा. There are some assumptions with the ideal spring. We assume ideal spring to be massless. Okay? Yes or no?
yes,
Initially,
Yes, sir.
when no force is applied on the spring, it remains relaxed and unstretched as an it remains relaxed in spite of writing unstretched. It remains relaxed at its original length. Let's say L naught. Okay. So here, when it remains at its original length, no spring force will be present. Is this case clear, guys? First case, when you know this spring is is at its natural length or original length, will it be experiencing any force? No, right?
no.
No. So always remember this thing. So this is all about the ideal spring. What else can we write in ideal spring? You know, always remember.
So what
Uh,
do you mean the no spring force is present in a spring force?
कभी स्प्रिंग को खींचा है तूने? Have you
Uh,
तो तेरे पे एक हाथ पे फोर्स लगता है जो तेरे हाथ को वापस से उसकी तरफ पुल करता है.
yes, sir.
That force is basically the spring force.
So it's not present in an ideal string.
हाँ, when no force is applied on the string, then उस पे कोई force नहीं present होगी. So always remember, a spring has a tendency to apply a restoring force. Apply a restoring force in the direction opposite to the deformation. This restoring force only, this restoring force is called as the spring force. Is this clear, guys? So this restoring force has a name. For example, suppose if I have a spring which is, let's say, connected to a massless plank or anything like that. Initially, this is at its natural length, let's say L0. Now I can do two things. I can either compress it, I can either stretch it. So let's say in the first case, I'll stretch it. So when I stretch it, will the figure become like this? On applying a force F external, can you see when you apply, when you start deforming it from here itself, when you deform it, is there a restoring force which acts in the opposite direction of deformation? Can you see you deformed it towards the right? Let's say the deformation was x. Was this your x, guys? Here, what is x? X is basically the deformation. It can be compression or it can be expansion. Depends upon whatever be the case. So you can expand the ring or you can compress the ring, right? First case is this. The second case is, wait, let me write it properly. So basically, this is the case for expansion. Hmm. This was the original length L0 and you expanded it. नहीं यार ऐसा मजा नहीं आएगा. Wait, guys, I'm drawing the diagrams again.
So
I'm drawing the diagrams again for you to understand it better.
restoring forces which puts it back to the same shape.
Which tries to put the object again back to the same shape, same spring to its original length. That's why it was restoring in nature. So when you started applying the force, and due to this force, let's say the spring did some deformation or expansion in here in this case. So will it look like this? Will it look like this?
Why?
So here in this case, there will be a restoring force which will be acting in the opposite direction of the
Expansion.
deformation. Can you see the deformation? The deformation was expansion. So can you see this restoring force is trying to reduce the expansion? Similarly, the same force can be Control C, Control V. So I can do this as well. So can you see, guys, if I apply an external force to push it, so can you see on application of this external force, when it gets a little bit deformed, a restoring force acts against. Can you see? The restoring force only job is to restore the shape of the spring, right? That's why its name is restoring force. So can you see if the deformation was towards left, or the deformation was to compress the spring? Hence, this restoring force was acting against this compression. So did you understand this particular point? Particular point, it always gets gives a restoring force whose direction is in the opposite direction of displacement or deformation. Yes.
Yes, sir.
Please draw it. At least I'll introduce the force today and we'll do the numericals in the next class. We did the complete weighing machine, the numericals based on that in today's class. Next class we'll do spring. And after that we'll start with constraint relations. So once those constraint relations are done, only last topic will be there, which is basically a pseudo force. Then NLM chapter over. Then we'll move on to friction. Okay? Okay, guys?
Yes.
Yes, sir.
And so anyways, next point, write down about spring force. Sorry. Next point about spring force, please remember. This restoring force is directly proportional is directly proportional to the deformation length. मतलब जितना we displaced it from this position, from the original position, more the value of this x, more will be the magnitude of this fr. So this restoring force is directly proportional to the deformation length. That is, more we compress, we don't call it expand, we call it extend, right? We call it extend or expand. Expand is different, right? Extend is something else.
Extend is
Extend
badana,
is,
expand is badana.
extend is badana, right? That is the correct word, right?
हाँ.
So it is not expansion, it is extension, right? So more we compress or extend the spring, the more we deform the spring, the more restoring force it applies. So if you keep on compressing a spring, then the force will keep on increasing until and unless your force and this external force and this restoring force doesn't become equal. Till that time, the length will keep on changing. So more we compress, extend the string, more restoring force is generated. Also, the direction I told you opposite. At one particular the length of the spring keeps on changing till the time the external force applied, or in spite of writing in words, can I write it like this? External force is equal to the restoring force. Can I write like this? Till the time the magnitude of external force is equal to the magnitude of the restoring force. Can I write this point, guys? Any doubt? So always remember, guys, if we have this particular case, so can you see this x and this fr has a relation? Fr is directly proportional to x. So I told you it is directly proportional to deformation length. When you remove the sign of proportionality, you introduce a constant, right? That constant is k, and this k is called as the spring constant or the force constant of the spring.
Sir, अभी हो गया?
हाँ थोड़ा सा बचा, थोड़ा सा, ये last one. So k is called as the spring constant or the force constant. SI unit will be, what is the SI unit of this? Can you say Newton per meter? Can you see this from here? SI unit, k is equals to force divided by displacement or deformation, right? So Newton per meter. Dimensional formula, I think you people will be able to calculate it easily. It's a scalar quantity, always positive. Okay guys, so this is the information upon k. K depends on material of the spring and the thickness of the wires used to make it. So basically, K depends upon the thickness of the wires which are used to make the spring, as well as the material of the spring. Is this clear? We'll later on know some more facts about this particular thing. अच्छा, vector wise always remember Fr is equals to minus of kx. We'll always use this only. We'll not use this vector form because direction we can guess and magnitude will, right? So Fr equals to minus kx. Negative sign represents that restoring force acts in opposite direction. Of that of deformation. Always in the opposite direction. So if you deform to extend it, then it will try to make it back to its, try to reduce the deformation. Okay. Is this clear, guys? So this is all about your spring force in the next
सर
class. हाँ,
ले लिया,
क्या भाई?
1 मिनट ज्यादा ले लिया.
अगली बार से ब्रेक मांग के देख तू, उसके बाद बोल के सर यू डिडंट अर्ली ब्रेक. अब दूंगा भी नहीं अर्ली ब्रेक. चलिए फटाफट लिख लीजिए एंड दैट्स इट फॉर टुडे.